Okay, hello everyone to the last episode of our little series. And in this episode, we will talk about how we can make reinforcement learning more sustainable when using it for the problem of controlling the traffic lights in a city. So we will look into results of some experiments that we conducted. And as it usually the case with traffic signal control methods, these experiments were conducted in a simulated environment. And we will be comparing the following methods. We have fixed scheduling. We have a greedy demand-based method, which basically prioritizes the phase with the largest number of cars awaiting on the adjoining movements. The analytic method, which is based on short-term arrival anticipation and which aims to promote green waves and positive interactions between intersections. And one reinforcement learning method, press light, and another one that will show to be more sustainable, guided light. And it's worth mentioning here that the adaptive methods, so that would be all of them except for fixed scheduling, operate on the level of a single intersection. So in that sense, they're decentralized. Here we can see some results. So of course, there are many metrics that can be used to assess the success of these methods. And here, for the sake of simplicity, we'll just use throughput. So that would be the total number of cars that went through the system in the simulation time. And of course, the more cars, the better. And we used 6 different simulation settings. That would be, different road networks and flow settings. And the last 2 scenarios correspond to parts of New York City. With some realistic flows. And these methods here are compared to fixed scheduling. So fixed scheduling is one, and then anything above that is better. And we can see that everything performs better than fixed scheduling. And then analytic and demand is usually somehow similar, and it's outperformed by the 2 machine learning methods, guided light and press light. And of the 2, guided light is a bit better and significantly better in the biggest, most complex New York City 196 scenario. But so far, we haven't really mentioned the sustainability angle. So we can just say, well, we have a better method of control traffic, so the sustainability is likely to be higher. Because there is less congestion, and as we know, congestion is quite unsustainable. However, another potential source of unsustainability is actually the training of the reinforcement learning models. This tends to be quite computationally expensive, and these models sometimes need to be retrained frequently. So generally, we would like to address this problem. The models need to be exposed to large amounts of data to be able to outperform alternative methods. And here we can see the learning episodes required by the machine learning methods to converge. And it can be seen that about 50 training episodes are needed for the guided light method to reach the level of performance of the analytic solution, while press light needs around 75 episodes. And thus, we could consider guided light a more sustainable method than the alternative reinforcement learning press light, since it just requires less training, less computational power, and so less resources. But how was guided light able to converge faster? And in fact, guided light uses the same state and reward as press light, and its overall architecture is very similar. The main difference, however, is that guided light uses a clever heuristics for its exploration. So instead of exploring randomly, guided light explores the actions that would be selected by the analytic algorithm in a given state. Thus, it is able to include some of the physics-derived analytic knowledge in its learning procedure, which makes it converge faster and to better results. Thank you very much for your attention. This is it for our short course into smart cities and traffic signal control. I hope you enjoyed it. Goodbye.